In this video, we will learn about the nature of stationary points. So let's say we had the curve that looks like this. Okay, there we go. Let's choose 3 points on this curve. Let's say that's point A, that's point B, and that is point C. So A, these are all stationary points, by the way, because the tangent to these points are 0, have a gradient of 0. Here, the point A is called the local maximum. Okay, B is called the local minimum, and C is called the stationary point of inflection. Now these are the 3 types of stationary points we need to be able to know. So let's look at point A first. Notice how the gradient before A is a positive number, right? Because it goes from left to right. And the gradient straight after A becomes a negative. Therefore, if the gradient is positive and then neutral, and if it goes down, that means the stationary point here is a maximum. Okay, now let's have a look at B. The gradient before B is a negative, and after B is a positive. So if the gradient looks something like negative, neutral, positive, that means this point is a minimum. Now let's have a look at point C. Point C has a gradient of 0 on the left and a gradient of 0 on the right. So this means if the gradient is just flat, that means that's the stationary point of inflection. And we call the stationary point of inflection SPOI. It's an easy way to say it, SPOI. So I'm going to call it SPOI. Now this is one way to find the nature of stationary points. Another way is by you can use the second derivative to find the nature of the stationary points. Now we know, let's say we had the function y equals 4x cubed plus 2x squared plus x plus 1. We know that the derivative of y is equal to 12x squared plus 4x plus 1. Now the second derivative is y dash dash, and that is basically the derivative of the derivative function. So we're finding the derivative of y dash. It's the same rule. You move the power to the front and take 1 from the power. So you get 24x plus 4. Yep. So that is our gradient function. And if we say we had, let's say, a stationary point at -2, 4, and at 5, 2. What we need to do is substitute the x values into the second gradient function. So if we find y dash dash of -2, that becomes -48 plus 4, which is -44. If this value is a negative, that means the point is a maximum. This you just have to memorize. Now y dash dash of 5, that is 120 plus 4, which is 124. Now that's a positive number, which means that's a minimum. So I think of like they're opposites. So if one's a negative, then that's the maximum, and one's a positive, then that's the minimum. Okay, so what if we had another stationary point at -1/6, and let's say 3. So that means, well, first substitute y dash of -1/6. That becomes -4 plus 4, that equals 0. And when this value is equal to 0, that means the stationary point is a point of inflection. or SPOI. So these three concepts are really important. You may want to use this one for most cases, but in some questions you might want to use the first method. It depends on the question. Now we'll have a look at some examples. Let's say we have the function y equals x cubed minus 3x squared plus 9x. And the question asks us to find the stationary points and state their nature. So our first step is to find y dash. So y dash is equal to 3x squared minus 6x plus 9. And to find the stationary points, we need to make y dash equal to 0. So 0 equals 3x squared minus 6x plus 9. You group everything by 3. 3 equals x squared minus 2x plus 3. And the x values are not going to be a nice number because you can't factorize this. That means we need to use the quadratic formula. Negative b plus minus square root of b squared minus 4ac on 2a. So here b is negative 2, so it becomes 2 plus minus 4 minus 12 on 2. Wait a minute. Something's wrong. Oh, sorry, this is supposed to be a negative. That makes more sense. That means this is a negative, and then we can factorize this. Okay, my bad. So we can factorize that into 3, x minus 3, and x plus 1. So the x values are 3, and x equals negative 1. Now we need to substitute these x values to find their corresponding y values. So if we substitute x equals 3 into the equation, 3 cubed is 27 minus 27, because 3 times 9 is 27, minus 27. So that's negative 27, and the stationary point is 3, negative 27. If we look at x equals negative 1, negative 1 cubed is negative 1. Negative 3 times negative 1 squared is negative 3. And negative 9 times negative 1 is positive 9. So that's 5. So the stationary point is also negative 1 and 5. Now our second step is to find the nature of the stationary points. So let's have a look at the stationary point 3 and negative 27. We find the second derivative of y, which is 6x minus 6. Easy. Then we substitute x equals 3. So y double dash is equal to 6 times 3 minus 6. That's 12, which is a positive number. Therefore, this stationary point must be a minimum. So we do a therefore sign and say the stationary point 3, negative 27 is a minimum. Now we look at negative 1 and 5. So y double dash equals 6x minus 6. 6 times negative 1 minus 6 is negative 12. That's a negative number, and therefore that is a maximum. And hence, the stationary point, negative 1 and 5, is a maximum. So that's how you solve questions involving the nature of stationary points. Let's try one more example. Let's say we had y equals x squared bracket 3 minus x. Our first step is to expand. We can use the chain rule, but it is inefficient, so we're going to expand it. Y equals negative x cubed plus 3x squared. So the derivative of y is equal to negative 3x squared plus 6x. To find the stationary point, we need to make y dash equal to 0. So 0 equals negative 3x plus 6x. Negative 3x squared minus 2x. So you can just cancel the negative 3 out now, because you can divide everything by -3, that would be still 0. So 0 is equal to x squared minus 2x. So that's x minus 2. Therefore, x can be either 0 or x can be -2. To find the corresponding y values, we substitute x equals 0 into the original equation. If we do that, we get 0 times something, so the y coordinate of this would be 0. If we sub x equals 2, then we get 2 squared outside of 3 minus 2. So that's 4 times 1, which is 4. Therefore, this point is 0, 0, and this point is 2, 4. Now to find the nature, we need to find the second derivative of y. So y double dash is equal to -6x plus 6. Same as our previous one, I think. So we substitute y double dash 0. That's equal to -6 times 0 plus 6, which is 6. That's a positive number, so therefore that stationary point is a minimum. We try y double dash 2. That would be -6 times 2 plus 6, which is -6. That's a negative number, so that's a maximum. Therefore, we can say that the stationary point 0, 0 is a min, and the stationary point 2, 4 is a maximum.